Okay. So first, I owe you all an apology. Actually, it was like a crazy day. I landed in Kiev in 9 a.m. and then my flight got delayed and delayed my connection to here, and then it got canceled around 1, and luckily Ole got me a cab that took me from Kiev to here, which is apparently a 7 hours drive. So it was a crazy day, but I'm so happy to be here, and thanks from everyone in Intellias for hosting us and for making this possible. And it's a great opportunity for me to be here, and I'm thankful for taking the time and listen, and thanks for everyone watching this at home. So I call this session from developer to architect for those kind of sessions, because back when I started to move from being a developer to take my next step when I came to my professional career growth, I thought that I was missing some key points, some places that I could look for and find the right way, to be an architect, or the right place. So I started to look for places online, to being from being an excellent developer, which I'm pretty sure that all of you are, and to being a good architect. And in this session, what I try to do is have some key points from being an architect. So I'll start by the most soft skills about decision making. We'll have some few minutes about this. Then we'll move on to how we better select our tools that we are using, and maybe have the same tool serving multi-purpose use cases in our architecture. And we'll end by we'll be using a drill down to microservices, and specifically to the messaging part of microservices, which I think when you come to architect or to design a microservices architectural system, it will be very important. I really hope that you'll find value from this session. So a bit about myself. I'm currently, my title is an architect at Playbuzz. I'm the first employee, so I had this opportunity to design the system at first to see what goes wrong, and a lot of it went wrong, and I'll show you in a few minutes what went wrong and how to avoid it in the future. And somehow, and we call it in Israel, and we stay alive to test our assumption. So yes, I stayed alive. It took like 5 years to build something that's strong. And we actually have an amazing team here in Lviv. I'm not sure where they're sitting, but I'm pretty sure it's around this office. Yeah, you're sitting around this office, yeah? So, okay. Yeah, so we have an amazing team here at Lviv, and we have a development team in Israel. Regarding my academic background, I'm just finished my master's in information systems management. My thesis and my research is in the area of distribution channels, which is probably a lot of what Playbuzz does, and the digital experiments, which I'm really curious about. Yeah, so let's drill down. So what is Playbuzz? It's important to understand the context that we are working at, because Playbuzz had a unique opportunity or unique place to be. So it founded in 2012, as I said, 5 years ago, by Shaul, our founder, and Tom, our co-founder. And we started like 3 people, and Tom and I were the developers, and Shaul was like the business guy. And if we fast forwarding those 5 years when we're having like a huge funding, that our last fundraise was 3 months ago by Viola Growth, and we have those 7 offices around the world, and we're growing and growing, and it changes the way that we looked at the software part. So what is Playbuzz on the product part? In a nutshell, we call ourselves a storytelling platform. And what do I mean by storytelling? There are tons of content pieces that are created online every day. And actually, and I have to be honest with you, I don't read most of them. And I'll give an example. I really like sports, so I'm getting into ESPN every day. And I'm not reading like half the article. I'm seeing the title plus the subtitle plus few photos. And then we needed to find the right tool to rise above this noise, and this is what we're doing. We give a publisher, and every publisher, like I have like ESPN, MTV, CNN, BBC, the tools to create this interactive content. And we're actually doing a good job, a pretty good job. We have over 200 million unique users a month with over 500 million page views, which is a huge scale. And we're going to drill down to the scale in a few minutes, but we're crushing the industry standard in terms of pages, time per session, but you're not here for all of these. You can see here some of the publisher, but you're here for the technology that's behind it. And one thing that I want to start with is what's unique in Playbuzz, or what's unique in this media business. We have a lot of companies that work on the SaaS business. And we found some differences, key differences when we're trying to define the SaaS business versus the media one. Well, in the SaaS business, we have the level of uncertainty that we have regarding the number of unique users that we're going to have every day can be thousands of, tens of thousands of users. In Playbuzz, we had one day that we got one of our first hit, and you're going to see it in a few minutes. We got 3 million people that come to our site without a notice before, and it was just like a peak. We published the story on Facebook, and I really remember this day because in like 20 minutes, we got the first 500,000, and then it just blowed, and it was amazing to see it. So the level of uncertainty and the level the fluctuation, sorry, when you come to the traffic, it's a key when you design an architecture that relates to the media world. So let's start with the decision-making part of the architecture. So when we're starting, I want to give you 2 tips that I got wrong in first. So I remember my first days at Playbuzz, and then I needed to create some kind of user service or an log service. So what I started to do, I created a service, a microservice at the time, or a macro service, that just got the request from the client and put it into a disk. It was the first version of it. And then I found out that I need to maintain it in a scale. And then I need to maintain those rolling files at the disk. And then I found out that I do something wrong. So the first point that I want to talk about when you're designing a system is don't do it yourself, or the more subtle version of it is buy before build. And I want to give you a thumb rule when you're deciding to work on a system, and it's about the ecosystem. If you try to build something that out of your core product, and you find that there is a huge ecosystem around it, you're probably doing the wrong thing for your company. I mean, I'm not talking about a $1 billion product that you want to buy, or $1 million product. For some cases, in our cases, in my log case, we just decided to use Logs.io, which is a managed ELK service. So you don't need, and we have Splunk and Logly and Sumo Logic, and there's a lot more, and CoreLogic now in Israel. So you don't need to build everything yourself. It's okay to use something that other one build to make sure you're concentrating on the right things for your company. So this was the first thing that I want to talk to, and the second one, I'm really talking about the soft skills when designing architecture, and then we'll start to drill down. And the second one is something that I really like. It's the hype-driven development, and you're all familiar with it. But sometimes it's worth mentioning. So when I'm talking about the hype-driven development, it's how, I'm not sure that you're seeing this on the end. No, I'll just go over it quickly. So every technology that starts to rise, it starts with the real problem. And let's take, for example, I don't know, serverless architecture, which is, I think, one of the latest that got. It starts with the real problem. No one wants to handle the load. No one wants to handle the servers and the architecture and the auto-scaling. So then it starts with the buzz and the keywords and the first talks in the conference when everyone starts to talk about those serverless thing. And then it becomes some kind of a mania. And this is the worst step to come into a technology. When everyone thinks that, serverless will solve all your problems and nothing will be the same when we see it, after you see it first. But then the next level, I'm not sure that we got to this one with serverless, but this is my opinion at least. The next one is disappointment. We found out it can't do anything. And then comes the realization, which is the best part of it. We know what are the advantages, what are the disadvantages, what are the pros and cons for using this technology in your stack. Or even better, we know what are the best use cases for use serverless and what is not. Actually, in Playbuzz, we were not using serverless because in our cases, it was just too expensive to use on our scale. I can give you another examples. We started with Cassandra. Cassandra was our first database. We had 3 servers, which is part of the initial cluster, and we had 10 records on our first day. So it made no sense to start with Cassandra. So we moved to MS SQL, which is another huge mistake, and we suffered that till that day. But let's push the MS SQL mistake to another time and talk about why we didn't stay with Cassandra. Another one, and this is something that I really liked when I first heard about it. It's an OOP, because I remember back then when I started to code, I was like 14, and I learned C++ and .NET, the first version of .NET, and I thought about OOP, and it's just like blow my mind. I thought like, whoa, we all think about inheritance. Like chair is just like a table and it all inherits from the same object, and it sounded amazing. But then after a few years, you just think that no, it doesn't work like that. And you started to implement more concrete method of thinking, like functional programming that we see a lot today and we like, or other types of modeling to your system. So if I need to summarize those first 2 points, which is like to touch the surface when it comes to decision making, it's not about when you're the architect or when you're a tech lead on your team, and you see a lot of startups that have this like logo in their like in Israel, it's really common to see it in the office, get shit done. And if I need to make a subtle difference, it's not about get shit done, it's about getting the relevant shit down. And this is the key part of your decision making when you're the architect or you're designing in a new system. So I want to move to the first architecture. So as I said before, we had our first hit and we got those a few millions of users. This is from the first day. We had 1 million likes in a day, which was amazing at the time. It was considered like a real hit on Facebook. So it was, who were you in your past life? So from this day, I learned 2 things, I gotta admit. The first one, in my previous life, I was an Egyptian princess. I gotta admit, yes. Okay, so we got this one on the table. Let's move on. So the second one is how do I need to handle those millions of users at once with a lean infrastructure? Because when you're a startup, you need to keep the infrastructure lean. You don't want to go to like millions of users on the 100 servers. You want to keep your infrastructure about 3 to 5 servers. And this is what we've done. So we use 2 simple tools, and this is where I'm talking about, I like to talk about the architecture toolbox. So, because a lot of times when I'm coming to design a system, I have my toolbox of infrastructures that I know or software that I know and really like to use. And there's the things that are in the company that are already implemented in the company and how we can use them. And we'll see it in a second. So the first thing that I really like is CDN. I implemented wherever I can to put this, wherever I can put a CDN, I'll put a CDN. And why is that? So the main difference is if I have one server, and these servers like serve the page views or serve the content or serve the static content. Let's start with the image. From a central location, you get like higher latency. But if I can move the server and take a server that is closer to the user, we'll get a better performance. And why is it helping us? When I'm using a CDN, I'm offloading tons of content and tons of requests from our server, from our origin server, which is like this server, to those servers, which called the edge server, which is owned by the CDN provider. But when you're using CDN, and I'll give some examples around CDN. So a lot of us know Akamai and Edgecast, and we have CloudFront in AWS, and we have Google CDN in Google. I'm not sure if there's, sorry? Yeah, and we have, again? Rackspace, they have their own CDN. I'm not sure. I'm not familiar with the Rackspace stack. Sorry, but they're all like Azure CDN, and there are a lot of CDN providers out there, and they're different in terms of functionality, and they're different in terms of pricing most of the time. So the main thing that they have, and you need to know, is know your users and your user base, and know which CDN to choose by that. So what we've done, we ran a few tests. Benchmarks between CDN to see what's the latency in the places that our users comes from. So you need to pick the right balance between the price and the latency, because for example, Akamai They have an amazing performance in Israel. They had an amazing performance, but it cost us like 4 times more than Edgecast, which give us amazing performance in South America, which we have a lot of users from. So you need to pick the right decision, and I'm pretty sure that if you run some benchmarks in your own company, you'll find the right CDN for you. There is a difference between a dynamic CDN and a static CDN. I won't get into this, but you're more than welcome to like email me in the end, and I'll be able to elaborate some more about this. And the first tool, like the actual tool that I want to put into your toolbox, if it's not already there, it's an amazing tool that's called Redis. And we'll talk about Redis in two aspects. One of them, it's an amazing caching tool, and we're using caching in the system a lot to handle the scale. The other one is how to take like one technology, in our case Redis, and implement it in multiple use cases in your system. And I'll go like in a few seconds, what is Redis? You're familiar with Redis? Yeah, great. So Redis is it's called an in-memory data structure style. It started back then. Now it's like, I think they have their own modules and other like added modules that you can add to your system and have some other functionality. But it's clustered today. Back when we started, it was like a single server or read-write, hot-cold cluster, sorry. But now they have like a full cluster. And the main issue is Redis, at least in my opinion, it's not like a fully persistent database. I won't use it as my only database. Okay? So it knows how to handle multiple types of data structures. Strings, which is like the most simple one, where we have like key value like every dictionary. Lists, pretty self-explanatory. Hash, which is kind of a dictionary that has like multiple keys, like two hierarchical keys. I have a key and then another set of keys and then values. Sets, which is a unique list, and sorted set, which you will see in a few seconds. So the first implementation that we had to Redis is the DB object caching. And I'll go very quickly over one because I don't want this session to go 2 times. So I'm comparing here 2 options, which is the write-through caching mechanism or the caching implementation versus the lazy caching initialization. And I'll talk about the main concept here, which is this one versus this one. In write-through, we're writing the cache, we're writing the object to both places. We're writing it to our persistent database, and we're writing it to Redis, for example, which is, in our case, our caching mechanism. In the write-through, what we're doing is, in the lazy initialization or the lazy loading, we're writing it only through the database and delete the old value from the cache. What do I achieve by that? I can easily get synchronous operation, like the database and the cache in sync, but the get gets more complicated. I need to get the item from the cache, and if it doesn't exist, I need to get it from the database and then get it back to the cache. And it gets more complicated, and we have some kind of a TTL mechanism. If we'll have time at the end, I'll elaborate some more about this because it can get really complicated, and I want to get through all our presentation and get through to the really interesting stuff. The next option, I'm sorry, just take a second. Sorry. So how do I manage lists? So we had this problem to manage the homepage lists, and I'm pretty sure that you're not seeing the green color, but I'll think about it for next times. So what we've done, you can add items to it, and you need to manage the homepage list, and you want to manage every new item gets on the top. So this will be the most simple implementation. So I'll just do a left push, L push, which is a Redis command, to the items list, which is my list, and then I call it a new item. And then in one command, I can get a full page. If I want the second page, I can get just the offset and get it in one command in a really low latency. It goes under a millisecond or 2 milliseconds for most of the cases. And what do I get here? This is the simple model, and we'll see in a second a more complex one. But what do I get here is one command that handles the paging, which one of the pain points we're using when you need to manage a list, and how to manage insert new items into a list, into a list that is already ordered in an efficient way. So let's get to the more complicated one, and then I'll hope that it will make sense. The ranked list. Ranked list is, you see it over here. So as part of our ongoing partnership with MTV, they had once a year the VMA, which is the, I think, Video Music Awards. Yeah. So they are running some kind of competition about the best, one of the competitions is about the best video clip of the year. So what's happened is they're going live inside and in their show, in this awards, and just saying like, you should all vote in mtv.com/blah/blah, and then everyone goes and votes. So we thought it would be like a few hundred of users, a few hundred of thousand, and we got 2 million votes in 15 minutes. And then you need to handle this in both ways. You need to persist all those votes, so this is what we use the database for. And then we needed to return a subset of the list, just the top 10 for a paging mechanism, to the users already ordered. And the order is not as simple like the up votes minus the down votes. You need to have some way to the recency and to the number of votes. Because, for example, if we have an item that got 5,000 votes up and 5,000 votes down, if you take just a naive implementation with up versus down, I'll get, for example, item with 1 up and 0 downs will be up there. So we need to take some kind of weighting between the number of votes and the mix between ups and downs and this stuff. So we use the sorted set, which is one of Redis objects. And again, you won't see a thing, but there is an implementation here of sorted set. So what we've done, I'll go over it quickly. The Z prefix suggests the sorted set commands. So we added to the ranked item 2 items with a score 1 and 2. You can see them over there. We got this member 1 with score 1 and member 2 with score 2. Actually, I missed the member 1 and 2 in the upper row, so ignore this one. I'll upload a newer version to the site so we'll be able to see it. And then we just changed the score of member 2 to 0. It's a O of 1 operation, so it's a really fast one. And then in another one operation, we're getting the list ordered again. So it looks really simple when you're talking about like 2 members and then 1 score change. But when it comes to, for example, in our case, 2 million inserts and 2 million gets, it gets way more complicated. And if you want to deliver it in a low latency, you need to do some things, some of those implementation or those performance tuning to make this work. I'll go quickly through our last use of Redis, which is another interesting one, but not something to talk about a lot, which is an output caching. So what we found out, we started with C#, because this was the only like the language that we knew at the time. Whoa, cozy. I'm not sure I'm not seeing a thing. Sorry, I lost my glasses on the first flight. So no, it's okay. I'm not seeing anything again. Again, my flashes. I lost my glasses, so everything. What you prefer? Yeah, it's better without the light. So. Okay. Yeah, it feels like I have a spot on my head. Yeah. But okay, we'll manage. So the .NET rendering is kind of slow, and you'll find out if you work in .NET. .NET, like today's .NET version of .NET Core, is way better than what we have in .NET 4. But again, the MVC rendering inside IIS was pretty slow. So what we've done to overcome this this challenge is we cache the output. You get an HTML output, and if it's non-user related, so you can just cache it. It's really simple. So you can cache it on Redis. So we have a distributed Redis on all our IIS servers, and then we just cache the results and get it back to the user from the IIS. So when using this kind of mechanism for output caching, it's really important to understand the content variance. And this is here not just because I had to add another bullet, because in the media business, or at least in our media business, let me be more concrete. In our business, we had at the time like 1,000 items that generates like millions of views, and then the other long tail generates like thousands of views. So what we've done is we serve those users who came to these heats, to this the 80-20 rule, to this 20% of the item that generates those 80%. User who comes to those pages got a cached page in like a very fast, a very low latency, and we actually make this like output caching even better by using dynamic CDN. And the edges are sitting like right near the users. We're using Fastly, which they have POP here in Ukraine that serves like this area of Ukraine and I think Poland. I'm not sure. So we can serve our pages not through a server that sits in the US. Our pages, like the pages of our hits, are being served from here. And the effect on the latency and the user engagements is crazy. And you'll really feel it you really feel it immediately, like if you're implementing this. So this was like the first part, the first evolution of our architecture. And then we had like an amazing moment, like some kind of an epiphany. Actually, it was really when the internet was down. That the team grew, and we had an amazing team. We started to create this team, our team extension here in Lviv. So we had some developers that joined our team. It's not like a separate team, and we found out that when we gave a developer to ramp up developer work into Playbuzz old architecture, was really complicated. We found out that it takes around a month until he understands all those caching, like the output cache, and then the lazy loading for the database, and then how to manage the list. And it was crazy, and we had some kind of like a weird architecture, something between a layered and a monolith and a distributed monolith and a saw, and it wasn't clear at all. And we found out that the main pain point for us was to ramp up new developers. It was to how we can work efficiently, a lot of developers on the same, like on our core functionality. And the level of knowledge that a developer required in order to implement a simple feature was crazy. It took us, like, for example, to have a simple feature at least a week. So it was crazy, and we had to like some kind of build it. So you know what, let's have some kind of a break, and I'll start with a nice game before we drill down into microservices and what we've done. Let's play a quiz, like the old Playbuzz quiz. Can we guess your architecture by the teams to services ratio? Okay, it sounds interesting. I know it's not like clear. I'm going to show you a use case that of a ratio between a team, between the number of teams in the company to the number of services that each team works on or tackles. And you need to guess what type of architecture it is. So let's try the first one. So I have a lot of teams in my company, but each team needs to tackle one player or one service on the other side. Can someone guess what type of architecture it is? Each team has work on one service. I'm sorry? No, the monolith is a bit different. We have a lot of teams in our company here, but each team has its own service. Again, yeah, SOA architecture. Who said it? Oh, yeah, so thank you. So it's SOA architecture or macro services, what we called back then. So each team has its own service. It's a big, like most of the time we divide it by the business use case. For example, in Playbuzz we had something like that. We have the big monolith in the middle, and then we have some business-related features like the save. All the how to handle the item on the save of the item was handled in one team, and they had their own services, and they were specialists in using this functionality, which is pretty sucks. And if you work like a year on a single functionality. So let's move to the next architecture. All your teams, and you have like 4 guys or 4 teams in your company, and all the teams, you're using them to tackle one service. I guess. Actually, you said it before. Amazing. Yes. So this is like a classical monolith. All the companies working on the same one, and we all know what the cause, like what the pain points when you're using a monolith, and this is what we had. All our our serving layer, our web server was kind of a monolith. in some sense, and it made like a hell to go through a feature, and then you commit your feature and you break another feature that just got into the queue, and it was crazy. Like when we grew from 4 to 5 developers, and in my opinion, the rule with monolith was just, it's okay as long as you can scream in one room, and everyone from the team will hear you that you are going to commit, and no one will like break your changes. But as it grows to multiple rooms, and especially to multiple places or to multiple offices, you need to think about something better. This one is a pretty tough one. Actually, no. You have a lot of teams in your company, and each team handles all the services in the company. Like I'm from team A, can handle services 1, 2, and 3, and someone from team B can handle services 1, 2, and 3. I guess it's not that hard. I'm sorry. I just like overshoot. So this is kind of implementation of a microservices, but this implementation have like a subtle difference from the classical microservices architecture. Because we're talking about microservices without actual, like, the teams doesn't matter. The teams are more of administrative. Because if I don't have like a core functionality that I work on, core, like I don't have my responsibility on a service or a functional or a business function, there is not like a lot of room for the teams to grow or for the teams to own the service. And the last one, you can guess, but like what's left. Like we have each team handles, like each team, here is the difference. Each team like handles multiple services.
Microservices.
Yes, microservices it is. Thank you so much. So yes, I know it's a pretty late and you'll all just want to sleep, but yes, thank you so much for your cooperation. So this is microservices, and this is something like what we've decided to implement, or what we're saying that we decided to implement, because in some senses, we're still trying to extract some features from a monolith to microservices. And this is a really interesting use case. I'm not going to drill down into it, but some people says that microservices are extracted, not built. I'm just like, it's a quote, but I'm not sure I fully agree with it. But in some sense, it makes more clear. You don't start with 1,000 microservices and then find out that these microservices have only one function, that you don't really need a microservices for that, and the Docker containers consumes more memory than what actually need. And you find out yourself that you're building like too small, like nano services. Not sure. Yeah, it's some kind of a nano services, and you need to have some kind of a fine balance between the functionality in one service and then what's inside it. Is there a question so far? Or, yeah, questions so far? Something? We'll have time for a question in the end. Anyway, but if you have something right now that relates to this one.
Did you actually try this previous architecture with microservices without teams?
So this one, when we started with microservices, we had only one team. So it was some kind of a microservices was without actual team and with actual teams at the same time. But I didn't see a lot of implementation for this one. I know that most of the big companies, like I know some like rumors from Facebook or from places I read, I'm not sure if it's accurate, that in Facebook you can create a pull request to any service that you want on your system. I'm not sure if it's right, but this is the kind of thing that you're working on multiple services and you can commit to any other service. Actually, in Playbuzz, there is some kind of like, it's not like you have an ownership on one service, but there are some differences. There are some requirements if your feature touches another service. So you won't wait for another developer from another team to wait. You wait 3 weeks and then he's ready for work on your service, and then like going on and on. You're all familiar with it. So what we've done is you can change service that another team works on. We just open a pull request and then they merge it into the code, and it works better than like classical microservices, which when you can't touch another group's code. Did it answer your question? Yes. Okay. Any other questions so far? No? Okay. So let's move on to a use case. So I'm going to drill down into messaging, and specifically to messaging when we're talking about microservices. In my opinion, or It's not my opinion. I read about it in a lot of books, and this is how it became my opinion. Messaging is the key part when we're talking about microservices. It's how the microservices communicate between themselves. And we're going to examine this use case, which is save. It's when you come to Playbase, then you can create an item. And when you're creating this item, and it looks like really appealing, and it's the story team, and we have actually a lot of from the story team works here in this office. And you can add an image, and you can add a text, and you can add a video, and all of those stuff, and you can add monetization into your product, or we are adding monetization into your product, and you can just click publish. And then the publish process became a bit more complicated. What do we mean? You need to save the item to the database. You need to index it in our search engine. You need to moderate to see if there is adult stuff or violence. And you need to tag the item for content recommendation. For example, find out that this is, I really hope this is Beyonce. Yeah, okay. If it's not, so you understand the example here. Just flow with me. So we need to tag like celebrities here and this specific celebrity and this, if it came from the VMA, for example, we need to tag this VMA, and we have to keep all those tags. And we found out that using it as a single process can be a bit cumbersome. So what we've done, we broke it down to microservices, and we'll see how we can choose, and we see a lot of use cases, how we can choose and communicate between those services and what we've decided to do, and what is the pros and cons we're using each and every one of them. And when we're talking about those, we'll talk about two aspects. The first one is sync versus async. I believe it's a known as a common knowledge, but let's go through it. And in the sync operation, it's this one. The client sends the save item request to the save service. It waits. It doesn't do anything until the save service returns the response, and then it continues to work. In the async implementation, the asynchronous implementation, the client continues and work and rendering the rest of the page or doing a lot of stuff that doesn't relate explicitly to the save. And then when it gets back these item details, he continues to work. It's the same use case with different implementation. And when I need to if I need to compare like async and async, I'm comparing them in a trade-off between latency and throughput for a lot of times. And we see it where you can choose. If you need a low latency, so probably like low latency, it's probably better to use sync operation between your services. It makes sense because if you need the client to get the response as fast as you can wait to someone to put a message in a queue, and then someone will consume it from the queue. And then you do its job, and then you create a callback to the first service, and then this service will send a message to the client that this takes some time, and this is the trade-off. And if you want to create higher throughput, for example, in event handling, you want to insert like tens of thousands of events per second. For example, in our event collector, we need to insert like 70 to 75,000 events per second, and you can't like respond to every one of them, do some work and then respond. So you just need to like say, okay, I'm handling this, and then put it on a queue. So this like the trade-off, and let's see some examples. So the most simple architecture when you're talking about like one-on-one services between here it's the save service and the indexing service, it's the synchronous operation. The synchronous operation will be marked with the full arrow, and the async operation will be with the dashed ones. So the request response is what we all know from the sync operations that we all work with. The save service, and we're talking for now on the server side, but it makes sense more in the client side also. Save service creates a call to the indexing service and wait to get back a response. In the async, and we have a lot of types of async, but in this case, it's just like file and forget, and it made more sense in event handling. But here you can just the save sends like a request to the indexing. If the indexing fails, the save service doesn't like care at all. He continues work like as usual. Next one, the request React. This has become a bit more complicated, but I'm sure you all saw it in different formats. The save service creates an async operation to the indexing service, but you want to know that everything is okay. So there are two options. He can either listen to a queue or send some kind of a callback as part of the create. And I see a lot of implementation with the callback. I really like it in terms of APIs that are long polling APIs. That if you want to create some kind of a request and then waits back to the response, you're just sending your request and then add some kind of a callback with ID. That when I'm finishing the work, I'll just call your callback, and then you'll get to know what is the result. Is this clear? Are there any questions by now? Yes, I'm pretty sure it's pretty late, so I'll move quickly. The next one is the orchestrator. The orchestrator is like in our case, we started to understand that we have some kind of a problem when the architecture was looked like the orchestrator. When the self-service works like synchronously, and not only synchronously, but he waits for every operation and then he needs to get it ordered. So he sent a request to the moderation service and said, hey, could you moderate the item? Yeah, sure. And then he waits a few seconds and then he gets back the response. And then he goes to the tagging service, hey, can you please tag the item? And both of them are third parties. One of them is hosted, the tagging one is, I think it's AWS recognition. And the other one is from Google, NLP, not sure what's the name of the service. And then after he ends both, so he has all this data and he merged everything, and then he indexes it and he goes to the Elasticsearch and can you please index it? And yes, sure, I'll index it. And then it goes on and on. And there is one thing that will be more worth, in my opinion, than the orchestrator is the service chaining, which the service gets the save service creates a synchronous operation versus the tagging, and then the tagging calls the moderation, and then the moderation calls the indexing, and then it goes back and back and back. And what's the problem here? It's like, let's take, for example, the moderation fails or the indexing fails, the whole operation failed. And when here, it's like, it's the same here, but then you have like someone who centralized it, who owns this process, and then he knows what to do. Here, when the management is distributed, it's way more complex to manage it. So the last example is the event-driven tree, and this is what we decided to do. It's like I'm presenting this. I'm biased towards this architecture because I really like it, and so take everything like I'm biased. So you create an async operation with all those services. And I'll show the implementation that we've chosen. It's a bit complex, and I'm pretty sure that, again, I choose okay. So it seems that those colors works. So what we've done, we used AWS SNS and SQS. SNS is a simple notification service, which just notifies some other services about event. And the SQS is simple queue service, queue like RabbitMQ, ActiveMQ, IBM WebSphere I'm not sure like which queues did you use, but it's a queue like every other queue. And then when the self-service gets a request, it just publish a message that calls save message notification to both of the three queues, indexing, tagging, and moderation. When the tagging service is done, it just like publish a new message, article tag notification, and then he publish it only to the indexing service queue. Because now he knows, at the indexing service now, I need to index this delta, those new tags. And the same goes for the article moderation. I know it's way more complex to handle and to think about it like that, and to I'm not sure about the implementation, but to maintain and to understand, like if I need to debug a message, it's really complicated. But on the other hand, if I need to rerun some of our message, like for example, we had a poison message in our system that creates like a lot of mess, and then we fix the tagging service, and now we know how to handle this. We can just rerun those messages to this queue, and we don't need to run it through all our services. Is this clear? I'm pretty much ran over it. So, sorry.
Can I ask a question?
Yeah, sure.
The event-driven tree, is it the same as service bus? Or is it different?
Yeah, it's a bit different. We have a difference. We don't have like a quarterback or the bus here. We don't have the real bus here because each service has its own queue, and then someone's pushed it into a queue. It's a more distributed implementation of a bus in some sense, because the SNS here is not like a single SNS, a single bus that serves those messages to the queue or serves those messages to the services. We don't have a central logic that says this message should go to here, this message should go here. Each simple notification SNS topic manages to his own queues.
And does it augment the complexity?
It is, but in some sense, it reduces the level of couples the coupling level with the bus itself. Because sometimes most of the logic, and I worked, like 10 years ago, I worked with Microsoft has Beanstalk, which is kind of, I'm not sure if it's a real service bus, but we had tons of logic inside the bus instead of services, and found out that a new message, we had to do a lot of configuration inside the bus instead of just configuring the servers. And now when we are adding a service, we're just saying to this notification, send it to another queue, and it's a very simple operation. I know that we had some trade-off between the complexity. Yes, I do understand that there are some trade-off that if you have a single bus, on one hand you have like single point of failure. When this bus goes, everything goes. But on the other hand, you get like one place that knows the configuration. So this is a valid trade-off that you can all think about it. So we need to go to the bottom line and summarize what we've went through. So it's the decision-making process that makes a developer an architect. And I gave you those 2 tips that you can take or not, but I think they make a lot of sense, but don't do it yourself or buy before build. Avoid hyper-driven development. Like, don't go to the latest technology, the sexiest technology. Just go with what you know or what you can implement or what you already have in your company. We talked a bit about the caching as a scaling mechanism, how we used Redis or CDNs to serve those millions of pages to all of our users with not a lot of work from our side. We keep the infrastructure in, like at least the server infrastructure lean. And we talked about the microservices messaging, and we talked about the latency throughput trade-off. We talked about the messaging types or the options that we have. And we touched a bit like a really small part of the error handling in what caused the failure of the chain, for example, or the orchestrator. So that's about it. So I'm just going to show you some places that I read a lot about microservices that I know. I hope it will make some of you interested in it. So I'm thinking a lot about the event-driven architecture a lot, and as I said, I'm biased towards it. The other thing is, of course, the Docker implementation, how I containerize every service, how I productionize it, and how am I going to work on it on a local host. So I'm seeing a lot of stuff on Kubernetes, which hopefully Amazon will support too as a managed service in the short, hopefully very, very short term, next few days. And this is the next step as I see, like in terms of implementations. The way to read, I read everything in Safari Books online. It's a pretty expensive one, but they have everything. And I just on the way here on the plane and on the taxi, I had too much time. And I read the latest book of Robert Martin, Uncle Bob. I'm not sure how you're familiar with him. About clean architecture. I'm not agreeing with everything, and and you're not supposed to agree with everything he said, but there are a lot of things that as he said, it's clean code. He has his own patterns or what he defines as anti-patterns when we're working on software. He said a lot of this about the architecture, and it's an amazing thing. And if you're looking at microservices, there is a specific book that I really like. It talks more about the how can I say, the theoretical part of microservices, which is the messaging, the data, the users, how you handle, and talks a lot about what we've talked today. It's called The Tao of Microservices. It's by Manning publication, and this link will just for you to the Manning shop. And who to follow? There are 2 architects that I really admire. They have a lot of programs that they're going through, and Safari Books online and on YouTube. They're called Mark Richards and Neil Ford, that most of the time come together. And they have a developer a program that calls From Developer to Architect. It's not my name. They're the one who they used it, or I'm not sure. I'm pretty sure they're not the only one. And I really suggest to follow them on Twitter, Twitter or on Cedars, their sessions to get more sense about what is architecture on the higher level. So thanks again, though. Thanks so much for having me here and stay pretty much towards the night. I'll be happy to take any questions if you have now, or if you feel more comfortable. If you're not feeling comfortable, just send me an email or Twitter or something. It all goes to the same device every time. But I'll be happy to take any questions if you have. So thanks so much for coming today. Thank you. sure.
Can you use a microphone so people can hear?
Yeah.
So I have a couple of questions, but I want to save your time.
No,
And
fine, it's okay.
only one. So regarding logs, where are you saving these logs? How you handle these logs? Yeah, I think it's a ton of logs you have.
Yeah. So I want to separate two types of logs. We have the application logs, and we have some kind of user-generated log, which is some kind of a user-generated activity, which we call events or user behavioral data. This is a different part of our system, and as part of my previous role in Playbuzz, which was the data architect, I created some kind of data pipeline to save those events. But leave them aside. How we save the application log? It's excellent. It's an excellent question because we're thinking about it all the time. So we have two types of monitors when it comes to the log. First, we implement New Relic on our servers to monitor all transactions. Then we have Logs.io, which is our a managed ELK that collects the log for us. And just as I said, buy before build or don't do it yourself. They're collecting the logs in high scale. They're indexing it in Elasticsearch they're doing the grokking part, which is pretty complex when you have multiple sources. And it works pretty well. By the way, so this is what we choose to do. Okay.
Thank you.
Yeah,
One more.
Yeah.
We start talking about Redis and why we choose it, because it works with memory, correct?
Yeah.
And regarding Spark also works with memory. But just want to hear your opinion. What is next? So memory is the top of performance, or what is next?
Yeah, so it goes to the unsolved fight between how fast can I get it and how fast do I need it. So memory is I can say in most cases memory is more expensive than disk or from compute. So it costs more to save it in memory. So Spark is a high memory system, and it's more for an ETL jobs or for a high scale of stream events. Redis in our case is more of we use it as some kind of a cache and not as a pipeline. So what do I do with it? It really depends on the use case. So I really need to hear more about the use case to understand what I think is the best solution for it.
Thank you.
Hi, thank you for your talk. You just said a bit about the events and the pipelines that you have. Could you tell a couple words about how do you deliver events and where you store it, like Redshift or what?
Oh, so we started this project 3 years ago. 2 years ago? 2 years ago, sorry. And we ran a benchmark between Redshift, BigQuery, and Vertica. Vertica is an enterprise database that was created by I think HP, and now it's called Micro Focus. Never mind, it's a more than an enterprise operation. And we chose Vertica, by the way. So this was the first version of our data pipeline. So what we've done, we took all the events, we implemented a very simple Java collector that runs on auto-scaled services on Amazon. And we just get the event, sends it into Kinesis, which is Kafka-like mechanism that's managed by AWS. And then we process it via Spark engine, Spark streaming back then. And then we put it on S3 for persistency, and then we load it into Vertica. This is the higher level. And now we created, it's a big bit of big word. We had our data team. We have a data architect that's called Dima. He created, Dima, our data architect, created an amazing evolution for this data pipeline, which have more persistency point and use Presto as a data lake, and then Vertica just for aggregation. Actually, I think I can send our high-level architecture with this presentation, and it makes a lot of sense that not using Stream, because Stream is very pricey, as we talked before when you're talking Sparks. You just can ingest everything to Kinesis and then just throw it into S3 as a first persistency of your raw data. Create another enricher that works on a batch operation, and then persist it again in your data lake, which is, in our case, it's just org files that we created Presto tables over. Oh, sorry, Presto query engine over. Sorry, my bad.
Okay, thank you. To see the diagram would be nice.
Okay, so I'm not having, or I'll look for it after that and I'll be happy to share it.
Okay, thank you.
Hi, thank you for your talk. I have one more broad question. It's about, you told us to avoid the hype-driven development, but the microservices are one of the biggest hypes last years.
It's an amazing question.
So my question is, what was the main reason you switched, you decided to split your monolith?
Okay, so that's an excellent question. Yeah, so microservices are high, but I think we've got to microservices for the part. Oh, sorry, I'll go back then. It's okay. Sorry, no. To kill someone like at 9:30 and he needs to go with the camera all around. When you're talking about microservices, I think in microservices we come to the realization what we can do with microservices and what we can't, in some sense, because we can run, for example, a high volume. How can I call it, like a heavy compute operation on microservice. For example, rendering, video rendering, got a lot of got back into a macro services instead of microservices that like have a lot of network traffic between services to render video. So why we choose it was more about the complexity of our system. We didn't want all the developers to know everything about caching and everything about database operations, and then override each other commits. So we decided to make some more. We're not fully microservices, I have to admit it. We are more kind of like in the middle between services and microservices, because we don't have the rule for example, for one persistency layer or one database per microservice. We have a lot of heuristics that we're doing and some kind of tricks that we're doing. But if I need to give a rule of thumb, so for example, we put in like a business operation or kind of a business functionality into a service in a more like micro way, not like all the save as we had before, more like what I said here. We have the save and we have the indexing, like business operation and the business value on the other side, that the tag, the moderation, that should be handled separately. I hope it makes sense.
It does. It does, thank you.
Okay. Just move the microphone. Okay.
I want to ask what you're using on front end and what do you think about module architecture on the front end?
So I have to admit that I'm not as strong front end. We're using Angular, but in the first version, like 1.4, 1.4, not Angular 4, just to make it clear. And the why is the migration is pretty hard when you're on high scale. Like every migration for us is like 10 times hard from what we've done when we had a low scale. Because now when we try to migrate like tons of functionality on microservices. But to your other question regarding a micro frontend, so this is like a module or a micro frontend. In my opinion, it can bring a lot of like what it brought toward the server side, which is a lot of flexibility when implementing each type. But when you try to load, and this is like an opinion, and I'm not sure it's like the most accurate one, but if you need your site to load as fast as you can, it's again this trade-off between the latency or the performance or the rendering time, and on the other hand, like the ease of creation or the ease of implementation. And in our case, I believe that it will be more like right for us to take more the performance side than the implementation side.
What about using a lazy loading for that modules?
Lazy loading can work. Sorry, it made me crazy, but I forgot the. Don't put it never mind. It's the Mac OS, yes. Yeah. Okay. Lazy loading can work for some cases, but in some cases it can't work for us. For example, in advertisement, and that we want to load to preload to have like the maximize revenue, or for in other cases like video that needs to being brought from third parties that we'll work with. But in some cases, if you can use lazy loading, I'll always be up for that.
You mentioned in next steps Kubernetes and Docker,
Yes.
And I'm wondering why you are not using, you don't want to use ECS because you're using AWS.
That's an excellent question, and it's I'm talking about the next phase when you're deciding what architecture. We currently use ECS. We use ECS for our production and for our staging. The main pain point that we have right now with ECS is how we can implement it on the developer's machine and in our development environment, because we don't have like ECS on machine, and you can run a compose, but then you can't run compose with CloudFormation to create your production. So we need to have some kind of a manual process between the developer machine or the developer process and to the production and the staging machine. So this is the pain point that we want to solve with Kubernetes and Minikube. Okay.
Thanks.
Hey.
One about database. You thought that you use caching, but my question is, you have a lot of microservices, and do you have one database and is all services connecting to one database, or you mirror the database, or how you solve it?
Okay, so to have one database for each service didn't make any sense for us, because, for example, we have today like 20 or 25 microservices, if I remember correctly. And to have 25 databases doesn't make any sense, for example, to handle like 25 Mongo instances or Mongo clusters, if I'm be more correct. So you can have like different collection per service, which you can like handle in one cluster or two clusters, and use this collection level of isolation, if it works for you. In SQL Server, we can have it on a schema level, or in RDS, it's way more simple because I don't like have any issue with maintaining too many databases. Because we still have some relational use cases that we're using MySQL for new features, and we have those unrelational NoSQL that we're using Mongo. I'm talking only about the application, not on the data side.
Okay, thank you.
Yeah. Any questions? Yes.
My question is about what is your opinion? How often should an architect practice hands-on coding? Should it do it at all in terms of don't do it yourself?
Oh, that's an excellent question. So I gotta admit that I don't practice hands-on coding as much as I want. But I know that if there's an issue in the company for any of the developers, I'm sitting with them and I'm drilling down to the code, and I don't have like any problem with getting my hands dirty and start to code with them. And there are a lot of cases that I'm doing a code review or not say a prep programming, but sitting with a junior developer and just develop it via some kind of prep programming. So I'm not doing a lot of coding myself. I don't have like a coding task myself. I really want to have some more tasks, but it comes with the company and with the architect itself. But I have to admit that I really want to code more, but I don't have the time.
Couldn't it be replaced with just code review of many teams?
Okay, so I'll be honest. This is the lies that I tell to myself, that instead of coding, I'm doing code review and it's going the same, but it's not. But yeah, this is kind of the lies that architects that don't code, or at least me tells to ourselves. Yes, sorry.
How do you document this huge architecture so that every participant could understand? You use these diagrams you showed.
Yes, we're using diagrams similar to this one. Yes. If you think that everyone can understand it, no, it's far from that. I can understand half of it. But if I need to understand it, if someone needs to go to a business case, he knows what the actors he have, like not like actor model, but actors like other services that he uses in the model, and how to connect with them, and then he just like points what he needs, and he knows how to connect via API. So it's more like again, I'm going back to the toolbox that every play buzzer have in his use. But you don't need to use all those toolbox, and you don't need to understand like all the tools on the same level. Does it make sense? Okay. Any other questions? Okay, so thank you all so much for coming, and sorry again for the late hour and for my late fashionably late appearance. I hope you got some value out of this session, and I really hope that if you have more questions, I really mean it. It's not like just say it. I really mean it. Feel free to email me at c@playbus.com or follow me on Twitter. Or as I said, everything goes to the same machine, so to the phone. So I don't care which vertical they use. Thanks so much.
We are really glad that you came, and next time when you are in the car for 7 hours, you can have hot tea.
Oh,
and,
thanks so much.
Thank you everyone for waiting and coming, and follow us at the Facebook. Thanks.
Thank you. All right.